And if you finish a little early, people will have some time back to do the break they should have had now. But we'll keep on schedule this way.
Okay.
Thanks so
Yeah,
much.
I'm not.
Uh,
I'm not going to take the full time.
I'll let you introduce yourself. So
Great. Thank you, Martin. Thank you, everybody, for showing up. My name is Dale McGinnis. I'm part of the America's Tech Sales team. So my client base is all of the Americas, here to support our sellers as well as the customers themselves. Spend most of my time on things like POTs and POCs and uh, driving requirements back into the lab. I'm sure Carrie is tired of me hounding her for feature enhancements, but that's part of my job. So today we're going to talk about something that I'm seeing more and more requests for, and that is I want to get off of AIX and onto x86 Linux. And why? Well, there's a number of reasons, but at the forefront of it is really I want to prepare to migrate to the cloud. Because as you're aware, most of our cloud offerings are Linux based. So you can't jump directly from AIX to x86. So we'll talk about that today. We're going to go through some planning, some resource sizing, automation, what's the impact of cluster management. We'll take a look at different options with respect to the migration tools. We'll take a look at what does DB2 do to optimize on P-series. You're going to lose that if you go to x86. What are some of the things that we do on RHEL? And then a simple page on just some guidelines and some recommendations that you may want to follow. Okay, so first of all, it's the same database, whether you're running on P or x86, it's the same code. We just recompile it with a different compiler, right? So functionally and feature-wise, it will be the same. So I get asked that question a lot. Don't worry about it. It is always the same if you're running the same release, okay? Same mod pack. Now, you cannot just take a backup from AIX and shoof, put it into RHEL. It's just not going to work, and that's because of the Indianness, right? One's a little e and one's a big E. So essentially, you need to somehow load and unload the data, or unload and load. Now, if you're going to be doing that, this is a perfect opportunity to re-examine the physical and logical layouts of your database. So first of all, you can get off of SMS and DMS, please. Thank you. You can take a look and see, is this a good time to reevaluate my buffer pool allocations? Should I do things like take my LOBs, which I may have in the same table spaces as my data, and move them out, right? LOB data doesn't go through our buffer pool. So if they're in a separate table space, then you can enable file system caching and get better performance on your LOB data, whereas we don't want to do file system caching on our regular data because that's the purpose of the buffer pool. We're more efficient on using the memory for buffer pool services than for the file system cache. Okay, so this is a really good time to take a look at it. Maybe separate your indexes out of the table spaces, put them into a dedicated table space. That way you can put them into a dedicated buffer pool. And now you don't have to worry about your data purging out pages of your index, because your indexes are what's going to give you the performance for your queries. So this is really, think of it as an opportunity to modernize your database, take a look at your environment, and you get a do-over, and you get to do it right. So this is a perfect time. So what are the steps that you would want to follow? Well, there's a lot, right? First of all, you got to justify why you're doing this. It doesn't come for free. You got to take a look at what are the technical constraints. Do I have the hardware? Do I have the infrastructure? We're going to talk about the different techniques that you're going to use today. You're going to have to change your run books. You're going to have to potentially change the cluster manager that you're using for automation. So it's a non-trivial task to do this migration. I've worked with several accounts who have done it. We typically would take, a weekend outage to do the migration, but the migration itself is a very, very small portion of the entire effort. It's all the planning and the testing that you have to make sure that's in place ahead of time. Okay. So obviously, with COVID and with things becoming 7 by 24 by 365, we really want to minimize the downtime. So the different techniques that we look at will have different impacts as far as what the outage will be. Okay. But that's typically the number one requirement, is how do I do this to minimize the downtime when I'm doing the cutting over. Now, historically, I've always recommended, if you want to absolutely minimize downtime, use something like a QRep, a CDC, a logical replication, in order to minimize, right? So what we do is we have our side by side. We have the old system, we have the new system on Red Hat. We're using QRep or CDC to populate the data over. Works really well. There's one downside. As of 11.5, we no longer include the license for QRep as part of advanced packaging. So when you buy DB2 with the new packaging models, you get every feature in every edition, but you don't get any QRep. So that would require, what happened here? Something's going on here. Oh, there we go. That would require a special license. So if this is something you're interested in doing, come drop me an email. I'll give you the secret passcode to get a really high discount on QRep that you can use in order to do this. But essentially, unloading and loading the data is what's going to take the longest. And some of the guidelines are, if you've got a small database, you're better off just unloading and reloading than the process of setting up CDC or QRep. So it depends on size. And I worked with one account in Toronto that did this migration, and their guideline was if it's under 200 gig, DB2 move, unload, reload, poof. If it's over 200 gig, well, then now we're getting into a substantial amount of time to do the migration, longer outage. We're going to use logical QRep for that. So that was their guidance, and it worked out really well for them. So different techniques you can use. You can do DB2 move, right? Free of charge. Great for small databases. Short outage, not very long, very low complexity. We'll go through the slides, and more importantly, it's no additional cost. You can do a load from cursor using Federation. Federation server is built into DB2 now. All you have to do is set up your nicknames and you're up and running. Little more complex because you've got to catalog the database, catalog the node, create the nicknames. So it's a little more work, but not unsurmountable. And again, good for small databases. Import and load, or export and load, longer outage, no additional costs. Again, great for small databases. When we talk about large databases, that's when the last two come into play. That's when we look at HPU and logical replication. So HPU is really nice tool. It's fully multi-threaded. It bypasses the buffer pool, goes directly to the physical containers, and extracts the data. Now you can also do it from backup images, but then the challenge there is how do you process the data that occurred after the backup. So typically you would take an outage, run HPU multi-threaded, in parallel on multiple tables, and get the data and reload it. Or logical replication, primarily QRep, because that's what it's optimized for. This has a couple of benefits. One is minimizing the downtime, but second is it's the only one that gives you failback capability. So what we typically would recommend is setting up a bidirectional replication. So you have your AIX source, it's replicating to Red Hat, but then you turn on Red Hat to AIX so that once you cut over and you're running on your Red Hat system for minutes, days, hours, and you decide, you know what, I just don't have enough horsepower, I can't keep up with my workload, I want to go back to AIX, you haven't lost anything, right? Because we're replicating all that new data from the Red Hat system back to AIX. So it does give you that flexibility and capability to fail back, which none of the other systems actually do. Okay, sizing. This is one I spend surprisingly a lot of time doing. And people say, well, I got 12 cores in my P series box, so I'm going to get 12 cores in my x86. Sorry, it doesn't work that way. We have some spreadsheets that we use that compare the spec-J performance numbers of an x86 chip versus a P chip. And so we can, and this is an example that I did for one of my customers who was on a Power 9 924, and they said, okay, we want to go to a Xeon 6248. They're going from 3.5 gigahertz down to a 2.5 gigahertz. How many more x86 chips do I need, right? And in this case, it was almost 1.5. So they need 50% more core to run the same workload. So if I look at for a non-pure scale, it would take 5 cores on the P series. It would take 7 cores on the x86, right? Or for a pure scale, it's 8 and 14. Now, so that means, yes, I can move to x86. Yes, the hardware is cheaper, but guess what? You've just increased your software licensing. So pay me now by buying a more resilient hardware feature, such as P series, or pay me later, which is more licensing on the x86. Either way, you're going to be impacted. So just remember, 1-to-1 is not a match when you're going from P to X. Okay, and then if you're adding VMware and hypervisors and Docker, and that all adds overhead that you don't have on dedicated LPARs on a P series box, right? So these are numbers. These numbers that I used here are for straight workload. I'm not taking into account the overhead of hypervisors and VMware, but I do specify that I'm only running at 70% utilization. And we can change that. So if you're interested in doing this, contact me, give me the specs that I need, that the model number of the x86 chip, what model of P series, and I can tell you what the ratio was. Now we've seen it low, like 1.4. I've also seen it as high as 2.7 x86 cores PVUs for one P series. So it really depends on the make and model. Very, very important that you understand that it's not a one-to-one mapping. Okay, this is my handy dandy sizing tool. It's a spreadsheet. So all I need to know is the hardware. I need to know, and I'll select whether it's RPerf for 2006, whatever the common benchmark is between the two processors. I need the transaction rate, right? The database size, and then down here, what's the workload like? Is it light, single, or maybe a two-way join? Is it medium, which 2 to 4-way joins, or am I doing complex 7-way joins, right? So that will impact the workload. And then I also have the ability to say, do I want to do this in pure scale or non-pure scale? So put these numbers in. Over here, this is for an AIX system, so it's going to be the first column. And for 1200 transactions per second on a 50 gig database, I'm going to need to run the workload 5.9. To run it at 70%, it's going to be 8.4 cores. Okay. If I go in and turn pure scale on, then it's going to be the third and the fifth columns will get highlighted in green, and it'll tell me how many cores I need and how much memory. So easy peasy to do once I get the information from the database. Okay, I'm just going to keep an eye on the chat. Nothing so far. Okay. Cluster manager. Okay, so a lot of our AIX customers are using PowerHA or HACMP, whichever you want to call it, because it's very tightly coupled with the operating system, and there's some huge advantages to using that for AIX. The problem is that it's an AIX only application. So when you go to Red Hat, you can't pull along your PowerHA. So we do ship with DB2 for free the Tivoli System Automation for Multi-Platform, or TSAMP, that supports a shared disk clustering, HADR automation, and DPF automation. Right? And it runs on AIX and on Linux, so you can use it. You can also use any other external cluster manager. It's just not fully integrated. So if you're a VCS shop, all power to you. Go right ahead. You have Red Hat HA, whatever cluster manager that you use. We published a standard interface that can be used. Right now, the only ones that are using it are TSA. Okay, but that's done outside of the database. If you're not using TSA, then you are responsible for setting up the scripts. With one exception is VCS, because you buy VCS and then you can buy the HADR enablement feature, which is more money, to give you the takeover scripts. Okay, so you're going to be changing. Now, the most important part when it comes to setting up these clusters, and I'm dealing with several of the counts on this call by looking at the names, is choosing the appropriate cluster manager tiebreaker. Okay, so TSA supports TCP/IP, shared disk, and third node. And for years and years and years, the DB2 Haiku tool only supported TCP/IP, which was really easy to implement. Right? What would happen is if the two nodes lost connectivity to each other, they would ping an IP address, and if they are able to ping it, then they assumed they had quorum. And when we first released this, we said, that should be fine. And it is great if both nodes are on the same switch. But what we found is some customers have set up their network with some firewalls that essentially, because of a network outage, the two nodes could not talk to each other, yet they both could talk to the DNS server. So they both thought that they could become the primary, which led to a split brain. Okay, so network tiebreakers are the least reliable of the three, and is one that we don't recommend unless you're running on the same physical switch and you use the switch as the TCP/IP address, because if the two nodes can't talk to the switch, then they can't talk to each other. Okay. Shared disk is, I know a few accounts that are deploying it. There are some restrictions with respect to the file permissions that are required. We don't see a lot of people using shared disk. What we're seeing more and more of is the third node. And I spent the last 6 months deploying this at most of the financial accounts in the US, moving off of TCP/IP onto third node, making sure it's in a separate site, so that if you co-locate it and that site goes down, if you've lost the node and the tiebreaker, then the other node's not going to come online because it can't get quorum. So it's got to be somewhere else. Okay, it's very reliable. Essentially, it's a third node. When the two nodes, primary and standby, can't talk to each other, they both go and change or lock a memory resource on the third node, and whoever gets the lock wins and the other person loses. So they're not going to become the primary. So that means there's no possibility of a split brain. Okay. Carrie talked about pacemaker and our move towards away from TSA onto a pacemaker and core sync model. Just to let you know that for pacemaker, the third node is the only model or the only tiebreaker supporting. So this is a good time to be prepared to make that move, right? And when pacemaker does come out on all the platforms, today it's only available on Linux. The lab will be providing a tool to help you migrate from TSA to PureScale. The other really nice thing I love about pacemaker is that you can have a single tiebreaker for multiple clusters, right? Today with TSA, if you're using a third node, you have a tiebreaker per cluster. So if you got 4 HADR deployments, you need 4 separate tiebreakers, right? With pacemaker, you can do it with 1. So that's a really, really great way of utilizing your resources, and it's much less painful. Okay. This is really just a repeat of what Carrie has already stated. So 11550 includes pacemaker and core sync on Linux, specifically for HADR. We are in the direction of enhancing the pacemaker automation tool, which includes AIX support, which includes replacing TSA within the internals of PureScale sometime in the next 2021, 2022 timeframe to exploit the pacemaker. So that's our direction. I would highly recommend that you get on the pacemaker chain or train as soon as possible. Okay, tools. So what are our different options? So we can't just back up and restore. We've already stated that because of the Indianness. So essentially at the very high level, you're going to need to unload and reload. So that means extract the DDL from one database, create an empty database, rerun the DDL, this time though, taking into account how you want it physically and logically laid out with respect to containers, table spaces, and buffer pools, and then getting the data in. Now we'll take a look at a number of ways of doing it. So everything starts with db2look. So once you get it, the syntax is all described on this chart. You can extract all the DDL, right? Easy peasy. You get the single file. You can go in, you can make modifications, change the number of buffer pools. You can change the table spaces that parts of the table are in, such as the index and LUWs. But this is step 1, DDL. Okay. There are some gotchas, right? Specifically, if you look here at foreign keys, right? Because when you replay it, the DDL has to be replayed in the correct sequence, otherwise you could get potential errors. So we'll go into more detail about this, but this is just some warnings from cases that we've tried out. As I stated earlier, if you can, at the very least, put your LUWs in separate table spaces, put file system caching on. I know this was a huge problem. I migrated a customer from on-prem to Azure, and in Azure you buy the storage based on the IOPS. And when they moved over, they had put everything together like it was on-prem, and the performance was absolutely terrible. So what we wound up doing is, after probably 2 weeks of diagnosing and benchmarking, is pulling all the LUWs out, putting them into a separate table space, turning file system caching on, and getting better storage for the LUWs. And once we did that, then we were able to meet the performance that we had on-prem. So just be cautious when moving to cloud environments, that really separating the LUW data and the non-LUW data becomes even more important. And then of course indexes into a separate buffer pool. And these are all just best practices from our performance team. Okay. Don't forget, backup and restore. Our lowest level of granularity is table space. So this is a good time for you to say, well, these sets of tables I would always recover as a unit. So it makes sense to put all of these tables into a small number of table spaces because I'll always bring them back together. Okay, so again, opportunity for you to really clean up what may have been done by your predecessors without the knowledge about tuning that you have today. It's a chance to start over again. Um, if we just do a quick comparison with respect to outages, they vary. Load from cursor, it's kind of hard to say what it rates as. It's going to be dependent on the number of tables. HPU and logical replication are probably the shortest of the two. Do watch out that HPU is additional costs and logical replication. Now, this is a typo. It says depends on license. That's not true. I should say it depends on your ELA. Because if your ELA has IIDR, which is IBM Infosphere Data Replication Feature, then it includes CDC as well as QREP. Now, SQL rep is still for free, right? So we didn't take that away. You still have that even in 11.5. So this seems to be a duplicate chart. Okay, so looking at the strategies, we're going to look at DB2 move, which is probably the simplest and easiest. Load from cursor, which has an advantage. It doesn't require any additional storage. It's with federation built in. It's really just a bunch of commands you have to issue to set up the nicknames, and you're off and running. HPU, very fast but chargeable, and then replication. For replication, if you have columnar, then the source and target must be at least at a version 11.5.4 because that's when we introduced QREP for columnar data. Okay, if you're prior to that, then you can't do a columnar database. You're going to, not through QREP anyway, you'll have to do an unload, reload, or a DB2 move. Okay, so DB2 move, the output, the syntax is here. Just export in the database name. It'll create a bunch of files for each of the different tables, an IXF file. It'll create the LUW data files. So those are fairly simple to do. Once you copy all the files to the target, then you have to grant permissions. So you've done your DB2 look, you've created the entries on your target, you go in, you update the permissions, right? And then you just do a DB2 move import. So very easy to do, very simple. Ideal for your smaller systems. So if you're under 200 to 300 gig, just don't bother with anything else. This is a simple and easy approach for you to move your data. Okay, and then after you've done your move, so you've done the creating of the DDL, right, but not the foreign keys or the triggers. You import the data, then you're going to run the foreign keys and then the triggers, and then you rebind, and then probably do a reorg check, and you're up and running. Easy peasy. And if you want the instructions, there's a really excellent article on developer.ibm.com that goes into detail. Some of the information from the previous slides actually came out of this article. Very well written. Okay, I see a question from Martin. Do you have any comments on moving LOBs quickly? HPU is called low PU by my customer. Well, LOBs are a challenge, right? Because they're not lobbed. They're not put in the buffer pool. It's raw data. So unfortunately, I don't have a better solution right now.
Yeah, my customer was upset. And I know the high performance utility was written by another company. And when I went and spoke to that man at a IDUG conference in Europe, all he did was mumble to himself in French.
Yeah, lobs are a bit of a challenge, right?
Well,
but unfortunately, it is what it is.
Well, this customer had a 25
We can
terabyte.
only make suggestions for them.
Yeah, yeah, it was
Yeah, I know.
okay.
We have some challenges with people like they're running P8 FileNet,
Yeah,
where they have massive amount of
yeah,
lobs, right? I mean, 3/4 of the database is lob data on a FileNet system.
yeah.
So yeah, that those are hard to do.
And that's the same problem this guy
Okay,
had.
yeah. HPU again, very simple, easy to use. This is something the DBAs can pick up fairly easily. You just install it on your both nodes, create the control file, specify the migration, and you're pretty much up and running, right? And it's all command line driven. So this is a tool that it is extra costs, but it is multifaceted, right? So not only can you use it for migration, but this can also go against your backup images. So if you want to reinitialize your QA or dev environment, and I know with one of my accounts on Wall Street, their production database had, I think it was like 22 different applications going into it. But their QA and devs were application specific. So they didn't want to take the backup of production and reinitialize all these QA and dev systems because it was just a waste of space. So they use HPU to extract the specific tables per app from the backup image and reinitialize QA and dev. So it's a really good way of doing that type of work. So very popular. It's part of a bundle. So you can buy either HPU by itself, or you can buy what's called Advanced Recovery, Advanced Recovery ARE. Advanced Recovery, I don't know what E stands for. But it includes HPU, merge backup, as well as Recovery Expert. So it does all three, either singular or as a bundle. It's your choice. It's cheaper to buy this as a bundle. Second option is Federation. This is the one that I'm actually playing with right now. I didn't have time to give you a live example. I will have that ready for iDoug and actually walk through a demo in iDoug. But it's easy peasy. You take the DB2 look, get the DDL, create the entries on the remote database, right? Catalog your target and source. From the target system, you connect to the source, you declare a cursor, and you issue a load, right? Well, once the nicknames are created. So it's not difficult to do, but I will, and maybe what I can do is when I get the system done, which should be hopefully by the end of the week, I can send Martin an updated slide deck that actually has the real commands that you issue, and I'll show you doing 2 or 3 tables at the same time. So this is what you would logically do, and I will give you live real examples of me taking my AIX database and migrating it to Linux on a Fire system. Again, works well for small to medium-sized databases. Okay, logical replication. This is the one where I see more of our customers going to, primarily because minimizing the downtime, right? You already have a different set of hardware, so it's not like we're asking you to buy additional hardware. You're already moving from one platform to another, so you already have it. I see this for this type of migration. I've also see people using it for going from version 9.7 or 10.1 right straight to 11.5, right? When it comes to logical replication, it's hardware agnostic, it's operating system agnostic, and it's database version agnostic, which is really nice, because if you were to try to go from 10.1 to 11.5, you have to make a hop in the middle. We can't do that directly. And I was talking to a Wall Street customer, and they have over 2,000 systems, right? And there's about a third of them that are still on 10.1, and they want to move everything to 11.5. I said, well, have fun. You're going to do some hopping. So I'm really trying to convince them that logical replication is the right way to go. It just makes your life so much easier. Okay. There are some tips and techniques in the presentation to talk about RI constraints. A lot of people say, well, you shouldn't be running RI constraints with QREP. Actually, I beg to differ. I spoke with both development teams, and CDC says you should drop the RI constraints on the target database in order to make replication faster. When I spoke to the QREP development team, they said, we don't care. We've got fast replay, so you can keep your RI constraints turned on, and we'll be just as fast as without. Well, we'll be slightly slower than without them, but the effort that it would take to turn them back on later, it's not worth the performance penalty that you pay. So definitely keep the RI constraints on for QREP. This is just a slight overview, and as I said, the IIDR does include all three technologies. SQLrep is still included for free with DB2 version 11.5. Okay, so for QREP, you've probably seen this before. We have our source tables. We're using the log capture process to read the transaction logs, sending over committed transactions, and then applying them all in parallel. It's based on your queue definition. We have some intelligence with replay that look at what tables are in the query and what tables have outstanding work, and make sure that the writes occur in the correct order. But again, that's all taken care of for you. You don't have to figure it out for yourself. Okay, it is by far best of breed for parallel apply. It will beat CDC hands down without doubt. And you can do this both unidirectional or bidirectional. If you need help setting this up, we have some very talented people both in tech sales and in development that can help you out. Or if you need help doing a setup, we can potentially even do one in our IBM Garage environment. This just goes into more detail specifically about the details of QREP, which you really don't need to. Now, typically, when we're setting up QREP and we're going to leave it running for an extended period of time, the recommendation is you run the queue manager off of the database server, right? And you put it on a clustered system so that if something happens and the database fails, the entities in the queue are still available. For a migration process, because it's not long-term, run the queue manager on the database server. Keep it simple, easy peasy, and it's just going to make your life easier and make the migration more tolerable than trying to set up something complex with an external queue manager. Okay. Some of the replication challenges, right? And those of you who are using QREP today kind of know about this. Is, well, what about unique indexes? I thought QREP needed a unique index. Well, yeah, it kind of needs a unique index, but if you don't give us one, we'll use the whole row, right? So we do have techniques around it. I'm just looking, okay, I got 10 minutes left. Okay, so I have to speed up a little bit. So a unique index is preferable, but not a requirement. There are some challenges around generated always columns. So you have to be cautious when you're defining your DDL on the target side if it's generated always. We have some challenges around identities, right? So if you're going by die, then you don't want to have an increment by 1. You would want an increment by 2 and have them starting at different numbers. But this is a migration process. So for migration, since we know we're only going to have the data flowing in one direction, this is a non-concern for us, but it is if you're running just regular replication. Sequences, again, something else that is typically and historically a challenge for QREP and CDC, but again, because of the use case of a migration, it's a non-concern because the data is only going in one way. For LOBs, lobs are a challenge, as Martin stated. Even HPU has a challenge with it. The way lobs work in QREP is not the most elegant, in that when it sees a lob column update or an insert, the target actually goes back to the primary or to the source and does a select of that row ID to get the lob data. So lobs will increase the amount of time it takes us to replicate. If you can do some sort of initial load, that would be better, right? So with QREP, you can either get replication to move all the data, or you can say, I'm going to export my data, I'm going to load it into my target, and then I want replication to start as of a certain LSN. So that'll minimize this impact of lobs in QREP. And again, for RI constraints, even though they can be complex, they're not a challenge for QREP. We can handle them as is. Okay, I'm just going to finish up here. I'm going to skip ahead. Okay, got 3 more slides. So isms. So for P series, we often get asked, and I know Carrie hears this all the time, well, what do you guys do to optimize for P? Well, we try to stay hardware agnostic for the most part, because we're software. We should be able to run anywhere we want to. But we do exploit some of the specialized compiler optimizations for P. We do exploit things like the NX842 coprocessor, so we can offload the backup and the log compression. So essentially you can compress a backup image, and the elapsed time for that compressed backup will be about the same as an uncompressed backup, but it's going to be 20% of the size. If you didn't have an NX842, then the elapsed time for that backup image is quite a bit longer, because we have to process the compression data. We also use the P-Series SIMD functionality from Colner, but we're seeing that SIMD functionality bleed into the x86 chips, so that's going to be a wash, hopefully in the near future. With respect to Red Hat, so that is the preferred operating system by DV2 development. That's what they're developing on. Now, I've been out of the lab for 6 years now, but when I was in the lab, I was one of the old guys that still developed on AIX and still love AIX. But most people found, getting that amount of hardware and dedicated hardware is not cost effective. So development has moved to a Linux type environment. When we do install, we do make changes in the kernel so that you don't have to figure out what's the maximum shared memory or how many semaphores do I have to. We take care of that for you as part of the DB2 install process. So just wrap it up. Words of wisdom based on customer experience. 250, 300 gig. If your database is less than that, use DB2 Move. Make it simple, make it easy. For larger ones, and if you want to minimize or if you need to minimize the outage window, then look at a logical replication type solution. That will be your best bet. And please take this opportunity to fix the mistakes of the past by relaying out the table spaces, the indexes, the lobs, and the buffer pools, because you're not probably going to get another chance like this again to be able to really restructure the database to make it optimal. So with 5 minutes to spare, that's all I had to say. I'll just open it up for questions. I see Carrie's typing away. And no, Carrie, I have no idea when your apricots will be ready on your tree, but it does look like a pretty picture. Okay, so if there are no questions, I'll give you 4 minutes back or 5 minutes back in order for everybody to have a bio break. Martin, what time should they reconvene in this room?
It's Chris here. So it looks like we will be back at 2:30.
2:30, so 14-minute break. Excellent. Thank you very much for coming out. If you have any questions, my email address is on the charts. Don't hesitate, just drop me an email. Thanks very much and have an awesome day.
Thanks very much, Dale. Thank you again.